Your brain is not a frozen program, but a living universe that you can rebuild. Imagine that while watching this video, hundreds of new connections will appear in your head. This is your new potential, new opportunities, and new skills. Forget about boundaries. Neuroplasticity is the key to unlimited potential. Want to learn how to reprogram your brain, acquire any skill, even in adulthood, and unlock the hidden capabilities of your mind? Then get ready. So, neuroplasticity of our brain and how it benefits us. Imagine that during the time you watch this video to the end, about 700 new neural connections will form in your brain. 700 is more than the population of a small village. And each of these connections is your new potential, a new opportunity, a new skill. What if I told you that a person who could not speak or move after a stroke can be retaught to walk, communicate, and even drive a car? That an 80-year-old grandmother can master programming? That depression can be defeated not only with pills, but also by literally rebuilding the brain? Sounds like science fiction, but it is the reality of our time. Modern science has proven that your brain is not a frozen computer, but a living, constantly changing universe. It is capable of completely rebuilding itself until the last day of life. And the most incredible thing is that you can control it. Welcome to the world of neuroplasticity, the most exciting discovery in the study of the human brain. Today you will learn how to turn your brain into a tool for continuous growth and transformation. What is neuroplasticity? Imagine your brain as a huge metropolis with 90 billion inhabitants, neurons. Each resident is connected to thousands of neighbors by a complex network of roads. These are our neural connections. Surprisingly, this metropolis is rebuilt every second. Somewhere old districts and unnecessary connections are demolished, somewhere new highways are laid, fresh neural pathways are formed, and in some areas new residents even appear, new neurons are born. This is neuroplasticity, the ability of our brain to adapt, change, and rebuild. 30 years ago, scientists were confident that the brain of an adult is immutable. What is. Born without mathematical abilities, you will remain so. Received an injury, the function is lost forever. What died. That's what neurobiologists of the last century thought. Today we know they were wrong. Your brain is constantly changing. When you learn a new language, certain areas in it literally increase. When you learn to play the piano, special neural networks are formed. When you overcome fear, the system of emotional response is rebuilt. Today you will learn 4 key points. First, how exactly the mechanisms of plasticity work at the cellular level. Secondly, how the brain recovers from injuries and diseases. Third, how neuroplasticity helps us learn new things and change habits. And finally, how to create ideal conditions for transforming your brain. Ready to look into the amazing world of your changing mind? Then let's start our journey. Part 1. Mechanisms of neuroplasticity. Now we will look inside your brain and see how the real magic of change happens. Imagine that each neuron is a tree. It has a trunk, a cell body, roots, dendrites that receive signals, and branches, axons that transmit information further. When you learn something new, these trees begin to grow actively, new branches appear, dendrites, axons lengthen. And in places where the branches of different trees touch, a real magic happens in the synapses. There is a simple rule: neurons that activate simultaneously connect with each other. It's like treading a path in the forest. The more often you walk along it, the wider and more convenient it becomes. This is how the principle of synaptic plasticity works, which underlies all learning. But the brain can not only strengthen connections, but also weaken them. Unnecessary paths become overgrown with grass. This is called synaptic depression. That is why we forget unnecessary information. The brain saves resources by removing what is not used. And now imagine something even more amazing. In your brain, like in a fairy tale forest, completely new trees can appear. For a long time it was believed that new neurons do not form in adulthood, but it turned out that this is not so. This process is especially active in the hippocampus, the area responsible for memory and learning. This process is called neurogenesis. Several thousand new neurons appear in your brain every day. Most of them do not survive, but those that receive enough stimulation and find their place in neural networks become full participants in your mental activity. The fourth mechanism is myelination. Imagine that neural pathways are wires, and myelin is insulation around them. The thicker the insulation, the faster the signal is transmitted. When you practice a skill for a long time, the myelin sheaths of the corresponding neural pathways thicken. That is why an experienced pianist plays without thinking. His fingers move at the speed of thought. It is important to note that all these processes occur simultaneously and continuously. Right now, while you are listening to this information, your brain is actively rebuilding, new synapses are forming, useful connections are strengthening, myelin sheaths are being created. Required conscious effort, Clutch, gas, steering wheel, everything had to be controlled, but over time these actions became automatic. What happened? Your brain created a specialized neural network for driving, covered it with myelin for fast signal transmission, and transferred most of the processes to autopilot. Next, we will see how these same mechanisms work in the most dramatic situations. Want a simple example? Remember how you learned to drive a car. At first, every movement when the brain has to recover after serious damage. Part 2. Neuroplasticity in the recovery process. And now a story that demonstrates the full power of the human brain. Imagine a middle-aged man who, after a stroke, cannot speak, can hardly move his right hand, and does not recognize loved ones. Doctors shake their heads. The damage is too extensive. In their opinion, there is little chance. But a year later, this same person drives a car, works on a computer, communicates with his family. How is this possible? The fact is that healthy areas of his brain took over the functions of damaged areas. It's as if the residents of a destroyed area of the city moved to neighboring blocks and continued to work. Neurologists now call this the phenomenon of vicarious functioning. The brain seems to understand, if the left area cannot process speech, let's teach the right one to do this. And an amazing restructuring begins. Of course, this process requires intensive work. Imagine that you need to teach your left hand to do what your right hand has done all your life. At first, it will turn out clumsy, slowly, but with each day it will get better and better. This is how neurorehabilitation works. Sensory compensation is especially striking in people who lose their sight. Connections in the auditory and tactile areas of the cerebral cortex are strengthened. The brain reallocates resources. Areas that used to process visual information switch to analyzing sounds and touches. Have you ever wondered how a blind person can determine the size of a room by the echo of their footsteps? Or how a blind musician distinguishes the subtlest nuances of a melody? This is not compensation, but a real superpower that the brain develops, using the freed-up resources. But the most amazing thing is age-related neuroplasticity. For a long time it was believed that after the age of 60, the brain loses its ability to change. This turned out to be a myth. Older people can learn new languages, technologies, and even musical instruments. Moreover, active learning in adulthood protects against dementia and Alzheimer's disease. It's like regular muscle training. The more you load your brain with new tasks, the stronger it becomes. It is important to note the key principle of recovery. The brain responds best to intensive, targeted practice. It's not enough just to wait. It is necessary to actively train the damaged functions. It's like recovering from a leg injury. The more you load your leg correctly, the faster it will heal. Modern medicine uses this principle in revolutionary treatment methods. Virtual reality helps restore motor functions after a stroke. Robotized trainers force paralyzed limbs to work. Special computer programs train memory and attention. Remember that every day of delay is a missed opportunity. The brain is most plastic in the first months after an injury, but even years later it retains the ability to change. It's never too late to start recovering. Now we will move from recovery to development and see how neuroplasticity helps a healthy brain acquire new skills and abilities. Part 3. Neuroplasticity and learning. Each new skill is an architectural project for your brain. When you decide to master, say, playing the guitar, a real construction begins in your head. New neural highways are laid, entire districts of specialized connections are built. The learning process goes through 3 amazing stages. At first, your brain panics, huge areas are activated, as if it is trying to solve the problem with all its might. Remember your first attempts to play a simple melody? The whole brain was working to the limit, and it turned out, well, you remember. Then specialization begins. The brain understands, aha, these specific areas are needed for this task. Extra connections are cut off, useful ones are strengthened, movements become more accurate, more confident. And, finally, automation. The skill goes into the subconscious. Fingers automatically find the right strings. Even when you are thinking about something else, a stable neural network is formed that works almost without conscious participation. But here's what's amazing. The brains of professional musicians are physically different from the brains of ordinary people. They have enlarged areas responsible for finger movement and auditory perception. This is not an innate talent, but the result of many years of training. The same thing happens with London taxi drivers. They need to know tens of thousands of streets by heart. And what do you think? The area of the brain responsible for spatial memory is significantly larger than average. The brain literally builds muscle where it needs it. And now about languages. Each new language is a separate neural network in your head. Moreover, the more languages you know, the easier each subsequent one becomes for you. Why does the brain learn to learn? It develops universal mechanisms for assimilating language patterns. People who speak several languages have an amazing advantage. Their brains are more flexible, better at switching between tasks, and more resistant to age-related changes. It's like CrossFit for the intellect. It is important to note that there are so-called critical periods. The brain of a child is especially plastic in relation to languages, music, and motor skills. But this does not mean that adults cannot learn. They just need different strategies. The adult brain compensates for the loss of plasticity with experience. It analyzes better, finds patterns, and uses existing knowledge. Therefore, adults can learn languages even faster than children if they use the right approach. Want a specific example of effective learning? Musicians use the principle of spaced repetition. They do not memorize one piece to perfection, but alternate studying different works. This forces the brain to readjust each time, which strengthens neural connections. Athletes use variable practice, train in different conditions, change the pace, and complicate tasks. This develops the adaptability of neural networks, and students have discovered a method of active information retrieval. Instead of rereading the material, they test themselves, trying to reproduce the information from memory. This strengthens neural connections much more effectively. Next, we will talk about how neuroplasticity can change not only your skills, but also emotional reactions, habits, and even personality. Part 4. Emotional neuroplasticity. And now the most interesting thing. Your brain can not only acquire a new skill, but also completely rebuild emotional reactions. Imagine that you are terrified of public speaking. At the mere thought of the stage, your heart rate increases, your palms sweat, and you have trouble breathing. What is happening in the brain? The amygdala, an ancient structure responsible for fear, perceives the stage as a deadly threat and activates an alarm signal. All body systems switch to fight or flight mode. Logic shuts down, leaving only panic. But here's the amazing thing. This reaction can be changed. Your brain is able to learn to perceive the situation not as a threat, but as an opportunity. How does this happen? A key role is played by the prefrontal cortex, an evolutionarily young area of the brain responsible for logic and self-control. When you consciously analyze your fear, rethink the situation, look for rational explanations, the prefrontal cortex begins to calm the amygdala. This does not happen in a day. Constant practice is needed. But with each time, the connections between the prefrontal cortex and the amygdala are strengthened, and the old patterns of fear weaken. The brain literally reprograms itself. Modern psychotherapy is based on this principle. Cognitive behavioral therapy teaches people to recognize negative thoughts and replace them with constructive ones. It sounds simple, but the result is amazing. Not only behavior changes, but also the physical structure of the brain. Now let's talk about habits. Each habit is a neural loop. In the basal ganglia of the brain there is a signal, there is an action, there is a reward. For example, stress at work, a cigarette, temporary relief. The loop is closed and works automatically. How to break this vicious circle? You can't just get rid of a habit. Nature abhors a vacuum. It needs to be replaced with a new one. The same signal, stress. But a new action, deep breathing or a short walk, and a new reward, a feeling of calm and control. Forming a new habit takes time, an average of 66 days of regular practice, but then it works just as automatically as the old one. The influence of meditation on the brain is especially impressive. People who meditate regularly have a thicker cerebral cortex in areas responsible for attention and emotional regulation. They have a better developed ability to concentrate, higher stress resistance. But meditation is not the only way to train emotional plasticity. Practicing gratitude literally changes the neural networks responsible for perceiving the positive. When you write down 3 things you are grateful for every day, your brain starts to actively look for the good in the world around you. Physical exercise not only strengthens the body, but also drastically changes the brain. They stimulate the production of neurotrophic factor, a protein that helps neurons grow and create new connections. 30 minutes of moderate physical activity can be more effective than antidepressants. It is important to note that emotional plasticity works at any age. A 70-year-old can learn to cope with anger just as successfully as a 20-year-old. It's not about age, it's about the willingness to work on yourself. Now we will move on to the practical part and learn how to create the optimal conditions for transforming your brain. Part 5. Optimizing neuroplasticity. So, we have reached the most important thing. How to turn your brain into a machine that is constantly developing. How to create the conditions for maximum plasticity. Let's start with the basics, physical activity. When you exercise, your brain is literally bathed in a cocktail of nutrients, blood flow increases, mood-boosting neurotransmitters are produced, and the growth of new neurons is stimulated, but not all exercises are equally beneficial. Aerobic exercises are most effective, running, swimming, cycling. They trigger the process of neurogenesis in the hippocampus. Just 30 minutes of brisk walking can increase your ability to learn for several hours. Next, sleep is not a time for the brain to rest, but a period of intense work. During deep sleep, memory consolidation occurs. New connections are strengthened, unnecessary information is erased. 7 to 9 hours of quality sleep are critical for brain plasticity. Want to enhance the effect? Review the learned material before going to bed. The brain will digest it all night, strengthening neural connections. This is not superstition, but a scientifically proven fact. Nutrition also plays a key role. Your brain is the most energy-consuming organ. It consumes a fifth of all calories. It needs high-quality fuel. Omega-3 fatty acids, found in fish, form the membranes of neurons. Antioxidants, found in berries, protect against damage. Magnesium, found in nuts, helps transmit signals between cells. But the most powerful stimulant of plasticity is novelty. The brain loves new impressions, tasks, environment. Every new experience forces it to create new neural connections. Therefore, here is a simple rule: do something fundamentally new every week. Choose a different route to work. Try an unfamiliar dish. Listen to music in an unusual style. Talk to a stranger. Start learning a new hobby. It is important to note that activities that combine physical, cognitive, and social components are especially beneficial. Dancing, for example, requires coordination of movements, memorizing sequences of actions, and interacting with a partner. This is a comprehensive workout for the brain. The same goes for learning languages. You train memory, develop hearing, learn new ways of thinking. And if you also communicate with native speakers, a social component is added. Social connections in general are extremely important for plasticity. The brain is a social organ, it evolved for life in a group. High-quality communication, new acquaintances, joint activities, all of this are powerful.